Welcome everyone to SQL101. It's the fall 2025 version of this class in Omaha Data Science Academy. This is class 4, joining and merging data. And I'm Jeremy Bergman, the Omaha Data Science Academy. So this lecture is all about how instead of querying a single data source or storing data and manipulating data and updating and deleting and those type of operations in a single table, now we can take multiple tables. We can either connect them by a common key, or we can append data on top of each other that has similar columns. We'll also learn about a technique called subquerying. It helps you create a small query, and then you could use it in your larger query. So you can now break a query into multiple queries and multiple parts. We'll see that in action tonight, and very valuable for these skills, particularly for a data analyst. I think it's where data analysts really draw their best insights, is not just seeing a report or flat table or data. It's when you start bringing data together in a variety of different ways for the first time that you start to see new insights. Okay. But we're going to start with learning objectives. I updated this slide. Going to do some learning objectives instead of bullet points of what we're going to cover. So by the end of the class, we should learn about those SQL joins. We have a few different types of joins that we can write. We can write an inner join, probably the most common, that's directly connecting or combining two tables on rows that match. Your left joins, your second most common. They'll include all records. You'll have a base table, and then you'll have other tables that you connect to it. We'll see how that works tonight also. This would be, you'd have a table on the left. It'd include all the records from that table and then the ones that are matching. We'll do a full outer join for complete data sets. MySQL doesn't have an implementation of full outer join, but they'll show you what that looks like when you combine two tables together where they match, and then where either ones don't match and what the purpose of that is. And then the other learning objective tonight is unions and subqueries. So that's how you can either append data together or, yep, so that's no problem. I was just worried about you, actually. I saw you in Slack. Not worried about you, but I knew that you were here. All right. So unions and subqueries, distracted myself. Unions and subqueries is where you can append two data sources with common data sets. You can combine those into a single query. There are two different ways you can do that. We'll cover that. You can do subqueries in a from, select, or where clause. So you can do a query within a query. We'll see how that's valuable in a couple different ways. I usually use it in the from statement as kind of like, well, we can explain it when we get there, but you can use it kind of to cut down the size of a table and then use that table or result set within an outer result set. You could even nest these. With that point, you can build complex nested queries for advanced analysis. With subqueries, you can nest as many queries inside each other as you want. The database management system may get angry at you, but in theory that you could do that. Then we're going to go over common mistakes for both SQL joins and unions and subqueries. What are the common mistakes analysts make for the first time when blending data? We'll go ahead, move to the next slide. So as this class structured, this first hour will just focus on joins. A little bit conceptually challenging how you bring those things together, but once you can really visualize it, I think it makes sense. And then put the code along with how you visualize the data coming together. It'll make sense to you. We'll spend the first hour doing that. Second hour, we'll do subqueries and unions. Unions probably aren't the more challenging part. It's the subqueries, understanding how that works within different clauses in your query. And then we'll do examples of both at the end and doing that for analysis. Okay. So the last class, quick recap, is data storage, data management and manipulation is what I like to call that one, the old title of this class. You have your data definition language, so you can create all these database structures, tables, and views. Okay. You can do data manipulation language is you can do inserts, updates, and deletes. So you can manipulate that data once it's already inside the table in a couple different ways. You can add table constraints to put rules in what type of data gets into these relational database tables, which can be valuable for data quality. You can add and delete those structures, so you can reduce or add the number of table fields, columns within a table, or table constraints. And then at the end, we showed a way that you can import data from SQL and CSV files. It's not the most successful in MySQL, but if you have a data set, a small data set, and you want to import it into a relational database, you can do a CSV file, use the import utility within MySQL Workbench, and load that into a SQL table and query it. So this is really about storing data that has permanence, so it stays in those tables so that you can query it later. You can use a SQL language to program it or query it later. Either store it or manipulate it and then query it later. Okay, so what's the need for data manipulation? Now we're covering the first two parts. So creating new data sets and combining disparate data sets. So we're doing joins, unions tonight, and subqueries. This part is what being a data analyst is all about, is taking all this data, blending it together using SQL programming language. You can perform common queries, aggregations, and joins. So this goes on top of the knowledge that we've already built with basic queries, or your kind of like your straightforward single table queries from class 2. But now we are blending it and bringing in multiple tables into the same query. And then the other two, we covered those in class 3. So how do you combine data? The answer is SQL joins. You can be done using where or join clauses. So usually in the where, or I mean, always in the where, because you're specifying, well, yeah, always in the where, one way or another, sort of. But anyway, think of, you almost always do this in the where clause, because you're taking two tables and combining them together. And we use a join clause, and we'll see this in action tonight within the where. So an example is, usually your most common is an inner join. You'll select all of your fields from table A, and then you'll inner join table B where the keys are matching. So they have to have matching values. That's why the value of setting a primary key, like we learned in the last class, comes into play, is that you can join on a primary key, or sometimes what's called a foreign key, but always joining two tables where the values match. So what this diagram says, you have table A, you have all the records in table A, you have all the records in table B. The red is that you're only keeping the records from A that match in table B. So where A matches table B. We'll go through some examples of this, but what's a quick example? Say you have all these invoices in table A, and then you have customers in table B. Maybe you narrow table B down to new customers. And then you join in between the two. You take that like new customers, and they have customer ID, where it matches the customer ID on orders. So you're getting all the orders for new customers where your new customers match your orders. And we'll go through some examples to make these clear. Just wanted to provide that one. That one's the most common. Your second most common is the left join here at the top. So you'll keep all of the records in table A, plus only the ones that match between table A and table B. So this is useful if you have a whole bunch of records in table A and they don't necessarily have matches in table B. Maybe A is like all of the films you have in your database and B is rentals in the last 3 months. So some of these movies have been rented. It'd be all movies. Some of them have been rented. And you'd keep out and you would get the count of how many times. Potentially this would be like a rental count. And then the rest would be null since they haven't had any rentals. Instead of describing this too much, I just wanted to describe those to you. We'll go through a lot of examples here tonight. So there's also a right join, which is just the opposite of a left join. Your full outer join is probably the next common one after that. You keep all of the records that match, and then all of the records in A and all of the records in B where they don't match. I like to use this to see what records match between the tables and what don't match in A and what don't match in B. That can provide some useful information. And then there are just variations of your left joins and your right joins, and then your inner joins. So you could, if you did this, you could say join on A and B, only keeping the records in A and not where they're matching from B. So it'd be where B dot key is null. There's no matching records. It's saying I want to keep all the records in A where there's no matches in B. And this would be just the same, just the other way around. Your base table is on the right. And then this would be all the records that don't match in A, all the records that don't match in B, take out all the ones that do match. I think these other ones are most useful for finding records that don't match between the tables, those last three queries. So now that I've described all those, given a primer, let's start doing some examples. Okay. So inner join, I described this one. That's where you only want matching records. So an example would be show all deals that have been invoiced. Maybe you have deals in one, you have invoices in another. You match wherever a deal has been invoiced, and you keep all of those records from the two tables. A left join, you want all the records from the left table like we described. Maybe this is show all sales with product details. Show all sales with product details, even if the product info is missing. So this would be your sales. This would be all of your products. And maybe there's some missing products on your invoices. Your missing products on your invoices would be this blank, and you wouldn't see any results in your table. All you would see is nulls. So right join is just the opposite. You want all the records in this right table. And I always think of like a base table. I mentioned that in the last slide. Especially when you're doing left and right joins, I think of a base table as the table that you start with, and then you keep all the records in that table. So A is our base, and then you're joining to B wherever it matches A, but you're still keeping all those records in A. And the same for B. B will be your base table. And then you're keeping all the records in B and wherever it matches on A. So the right join would just be the opposite. If A is your invoices, B is your products, you would see all of these right here that all the products have been invoiced, and then you'd have nulls for anyone in the B where it hasn't been, where it's never been invoiced. Full outer join would be both. So you want all records from both tables. So you'd show all sales and all products, even where there's some sales that don't have products on them potentially, or products without any sales. So a lot of conceptual. We'll try to bring this down to earth in the next few slides. But one of the tips, like I say, most analysis uses inner join or left join. I would say that's probably 80 or 90% of your queries. Your full outer join is rarely needed in practice. I use it sometimes to see where all the missing records are between the two tables and where their match is. But still, it's kind of rare. It's like 5% of queries probably, usually when I'm exploring the data and seeing how data matches up between the two tables. I think you probably learned a little bit about this in Tableau. In Tableau, you can bring in two data sets, and then you have that editor that allows you to blend the data sets. So it's the same thing as that. We're just doing it with the SQL programming language. Okay. So let's see a live example of an inner join. So the syntax for the inner join, let me get my cursor back up there, is you can select your columns just like you do in a regular query. Still trying to find my pointer so I can show everyone, I can guide everyone with their eyes. Okay, there it is. Really want the pointer for this one. Okay. I saw my pointer a second ago. It's like the fly that's buzzing around the room. All right, well, anyway, your syntax over there on the left, you have select your columns. From your tables, you're going to select your first table that you want. Then you're going to select your second, or you're going to choose the second table that you want, but you aren't going to just use that as a from. You're going to do this new keyword or operation inner join, and then table as alias to. So these aliases you've seen, you remember we were able to rename columns to certain things. Say we'd say like column name as country in the world table. Now we can give our table aliases too. So we could call our first table, I'll often just call it A, or you can give it a more descriptive name. Your inner table and table 2 would be table 2. I would often call that as B, or you can give it your own name. And we'll see that over in this example. And then you have to define, when you do an inner join or other joins, you're defining what key are you joining on. So what field, common field between the two tables will help you match results in both table A and table B. So let's look at this example, bring it down to earth a little bit. Still looking for my cursor. Does that help? I'll describe it since I don't have my cursor again. I should just get out my mouse for this thing. But anyway, select star. What that will do, since you're joining two tables together, it's going to join the records from that Facebook table, and it's to the records of the LinkedIn table. So you're going to get all the columns from the Facebook table, as you can see down below, and you'll get all the columns from the LinkedIn table. So Facebook has a name column and then number of friends, and your LinkedIn table has a name column and number of connections. So the common field here, the key, it looks like it's going to be name. So when we're writing our query, we'd say select star, which gets the columns from both tables. From the Facebook, because you say from Facebook and join LinkedIn. And then when you're getting all those commons or the records that match on those IDs. So down below, so I like these illustrations because it goes record by record. This is exactly the way the database does it. And then when it finds a match, it'll put it in your result set, which is down at the bottom. So the first, it looks for Matt. It tries to find Matt in the LinkedIn table. It found it, so it put it in the table. It does the same with Lisa. It did not find Jeff, so Jeff doesn't go into that table. And it did find Sarah. So on that name column, we'll run a couple times. Wherever there's a match on the key, the columns from the Facebook table and the columns from LinkedIn table are joined into one data set. And that's why in SQL, that's how you blend two data sets or join two data sets together to create a new data set. So you could see this would be a good insight, because with these users that are on both platforms, now you could see as an analyst how many friends they had on Facebook, and then if they had friends on LinkedIn, you could see how many they had there. And maybe you could do some analysis or report or whatever you would do with it. So this comes from a website, has some practice exercises to give a try. So let's see when we write an inner join using the world.country table. So if you wanted to list all the countries with their official language, so now you aren't just getting information from country, you're now joining that and blending it with the country language table. And I think it'll be a good idea to pull this up. I always like to look at these tables individually to see what type of data is in each and what a possible key would be. So we'll go to the world table. And I haven't put this in the, I just created this example today. So I haven't put this in your lectures PowerPoint SQL file, but I'll go ahead and show you how it works here. I'm going to break it down into a couple pieces. So world.country, I like to see what's in each table individually. So we have world.country. This is where it's really helpful to right click on the table, just select 1,000 rows. I just want to see, like, you don't have to necessarily select the whole table, just like enough to know what's in each field, what type of information's there. And just from experience, it looks like code 2 may be a key, but even more likely this 3-digit code, country code. Oh, Celestia, you're asking, can I make an example file or a file with this code? I plan on including it in the examples, but I could just go ahead and do it right here and send everyone a file. If I can copy, it doesn't copy and paste out of there very well. Let's go ahead and I'll just type it in and send it to everyone. It's a short query. It doesn't copy and paste out of there very well. Yeah, not like it looks like it would. Put it on Slack, deal. Okay. So back to where is that? Let's do this. Okay, so I'm looking at world.country table. I have a pretty good feel. You can actually tell what the primary key is in this table when you look over to the right. It'll be bold and underlined. So that's why I said just looking at the table, code's probably a key, and maybe code 2. Let's look at what country language. Now I'm really looking for what's in country language and what a common field is between both of these tables that I can join by. So world.country has code. Country language looks like it has the same 3-digit code. And even this is a one-to-many relationship. So for every one country, there can be many languages. You can say like in the United States, let's just go down to the United States. There'll be multiple countries. Multiple languages spoken in the United States. B, C, D, E, F, G, USA. Hey, you can see a ton of them, right? Like from immigrants, Chinese. Immigrants speak Chinese. What percentage of the population? French, German, Italian. All of the languages. It looks like they mark the official ones in each country and some that are not. Of course, English is going to be official language. 86.2% of the citizens in the United States speaking English. Okay. Oh, really in joining tables, you need to start understanding what is in each table, what common field is there that I could start bringing these together, and then what information do I want? Like, what is the information telling me, and what do I want to put in my final query? So let's go ahead and do this. And then what question you're asking. So this one says, list all countries with their official language. And this might just be a good example. We just write this out. Okay. This will be good because we'll just do this here together, and then I'll put it in Slack. So we will select, well, actually, I think it helps to say what tables do we want information from first. So let's do world.country as A. And then we're working on an inner join. World.country language. These are the two tables we're getting information from. You're lost. We'll do lots of examples here. This is where I said this one's probably the toughest. This one's the toughest lecture. It's the toughest lecture to, we'll just need a lot of examples in this, lots of practice, understanding how this data comes together. You didn't? Okay. All right. Yeah, let me know anybody who has questions. I'll do our best. We'll do our best through all of this. If you have questions, just drop them into Slack. I have some questions already. Okay, no, we're still in the same place. Okay, so select from world.country as A, interjoin world.country as B. So we got the two tables that we want, the information. We have a common key. They say we want that information from world.country and world.country language. Our initial question is we list countries with their official languages. So we want country information, so we can get that from the world.country table. Let's put that in the backtick since name is a reserved word. Let's call that country. And then b.language. So we are going to get the language column out of the world.country language. Language. I put the backticks there on that one because you saw language is also a keyword in SQL. So to avoid any confusion, we'll just put backticks on it. And you don't have to necessarily do this as language either. If you don't add an alias, it will know that the column is language. From world.country as A, interjoin world.country. Okay. And then the last part is, not the last part, we need an on statement to tell the database what common field we're bringing the two tables together on. So it's a dot code. So it's a code field out of the world table. So out of the world.country table, this field is code. In the country language table, it's country code in that table. Okay, almost there. You could even see between the two tables that field is not necessarily named the same thing. It's code in one and country code, but they appear, they're both keys and they appear to have the same values. And then what you can also do, you can add another clause to this. You can do an and since we only want official languages, you can say is official is true. Equal to T. So let's break down what that does here. So we're getting all the records from the world.country table. We are getting at the start all of the records from the world.country language table. We are matching on the country codes. And then the step that we want to take is just limit this table to, and I'll even put the alias here, b dot is official is true. Just limit it to, on this table that we're joining to world.country, just limit it to not all of these records that are in this table. Like we don't want all of the languages in the United States. We just want out of this table the official languages where it's equal to true. So we take the country table and just official languages. Our query is going to have country names and languages. Let's go ahead and run it and see the result. And now you get the official language of each country. And you can see for a couple countries, they have more than one official language, which makes sense. And for the United States, it should just be English. United States. These are all in alphabetical order. Oh, that's not the right United States. United States is English, and that is the only one it has with it. So we got that result that we wanted. So we just really had to think, like, understand now. Before we just had to understand what columns were in a single table, and then what records we wanted out of it, what fields and columns or fields and records we wanted out of it, or columns and rows, and how to limit that. Now we really need to think about 2 or more tables that we're bringing together. What type of join we're doing is whether we only get the records where the 2 tables are matching. Do you do one where you keep all of them on the left and only where it's matching on the second table, or a full outer join is what you'd use most of the other time. So really you have to think about those parts, what your key is, and then what operation you're using now to bring it together into your final result. So I'm going to copy and paste this here. And I actually just feel bad for that about that. So I'm just going to stop here. After all of that, we did a lot of conceptual work at the front to get to this point in that query. Is anybody, I want to just open it up for questions to make sure everyone understands. Well, first, say what we're doing here and the purpose of bringing more than one data set or table together. And 2, like anything about joins or keys that we're joining on, or what any of this code means. I'm happy to take a few minutes to do that before we go through it. Here's Celeste. I'm going to paste this code also. You said you would talk through the language, like you want me to go through the language table? Drop me another note and let me know. Actually, it'd probably help. Talk us through what we wrote. Okay. So to recap, let's recap this. So we decided we wanted information. We wanted to blend information from 2 tables. We wanted information from world.country because that has all the country information in it. That has code, the names, populations, and so forth, even though we aren't going to take all that information for this query. And because the question is list all the countries with their official languages, we know we need information from the country language table. But we don't know that, but you would have some knowledge of the database and what are in the database tables that you explore to find what you need. So if you're an analyst, you would know, probably you'd be like, okay, we have languages in the country language table. So let's go to the country language table to try to get that information where the official language is equal to true. Okay. So let's go take another look at this table. Select star. I'm just exploring it. Just want the top 1,000 rows. I do this commonly to understand what's in the table. I'll get to that in a second. Celeste. But we just want these records. I'm going to write this. Where official language is official is equal to T. Okay. So now, like, this table is what we want out of, or this is the result that we want out of these two. We want the countries out of the world.country. We want country languages out of your country language table, and not just country language, the official languages. We want to bring these together. We want them where they just match each other by country code, because we saw these have the same values with the two tables. And Celeste, that's where you use the on statement. The on statement will say, I want to join these two tables on their matching key. So let's go back to this query. Try to expand this. Oops, that wasn't the right one though. We were working in this one. So we decided we needed country information. We need country language information. We want to interjoin where all these match each other. And then this on statement says we're joining on this matching key between the two tables. That's how we get our matches and the records that we want from each table. Yep, you got it, sir, online. You're welcome and watch along. Sometimes we have people who are watching live online too. Someone dropped us a comment. Okay, and not only from that table B, we do on country code. We can also do a limiting condition on that table that we're joining, and we say and is official is equal to T. So this limits that country language table to where the language is only the official language. So you're taking all the countries, you're joining the country language table, but the records that contain the official language and where all those two match. So it blends it together. You got this country name, and then you have the official language that goes with it. So that was step by step. Anybody else have questions, or is there a good way for me to maybe restate if you currently don't understand? It may just take some time, some hands-on. I know sometimes I'm doing like mathematics, taking a mathematics class, I just have to get my hands on it. If you feel it's useful to do that and type along the way, or maybe it'll start to click whenever you start doing the homeworks, I'd say don't give up. There are lots of resources out there. And of course, there's my help. But break it down always. If it's hard to understand, break it down into those smaller pieces like I did. Take those smaller pieces, and then with the SQL programming language, you can start putting all those pieces together to get the information that you need from multiple tables and data sources. And that's even how I do it in practice. So I don't write just like a 100-line query or anything like that. I break it into my own small parts, one by one, and then I assemble it together. But for the first time, don't despair. Try not to be overwhelmed, and we'll all get there together. Okay. So that's good. Anybody else have any questions? MySQL does use CTEs. We will learn that in the advanced SQL class that we have coming up in 2 classes. That's like another way to kind of write a subquery. There are a couple of different ways that you could use, or you can write queries for advanced analysis. We will learn subqueries here. I kind of like using CTEs a little more. They tend to be better performance, but we'll get to that. We'll get to that in this class. It's something that I've started including in SQL 101 because when you're geared it for data analysts, using things that could create intermediate steps like I was talking about in the query, SQL query to break it down, like CTEs are a good example of that, or temporary tables. We'll learn about those too. Anything that you can use to break it into smaller parts is like result sets, and then reuse those result sets to bring it all together in one is helpful. And I prefer CTEs to subqueries, but it's important tonight to understand how subqueries work so you can understand how the rest of it works. Conceptually, how SQL is bringing together the data. That's why I said this class is one of the hardest because it starts to become conceptual. You really have to think about what the SQL code, not only what your SQL code is doing, but break it into, it's like a problem, break it into smaller parts. And then how does SQL bring that together through joins? That data through joins, or a couple of different ways. How does it process the data to start to get the result that you need? All right. So we're gonna move forward. Feel free, anybody, to ask questions at any time. Okay. All right, let's do a left join here. I must have forgot to paste the left join results in there, but we'll go through this step by step. It's actually a very similar query. So we already have this base query. We're going to see which countries do and don't speak English with the left join. So maybe I should have got to these examples a little faster, but I wanted to frame the background for it. So, okay. So this question is, and it's always important to remember this question that you're trying to ask is, which countries do or don't speak English? So you want to keep everything, all the countries here in A, and then you're matching or not matching the columns from B where the language is equal to English. So keep all the countries in A. You're going to match all of them that are English. You're going to keep that in the result set. And all the countries that don't speak English, they'll have null values from table B. So let's see this in action. I like these examples that I put together today because they're just small changes to what we're doing. So this one's going to be as simple as changing this inner join to a left join. So we're selecting the country language like we did before. We're using the same tables. We're joining on country code, which is our key or field that matches in between the two tables. But instead of the official field in class B, let's go ahead and take a look at that table again to see if there is one in the country language table that will help us with language is equal to English. I just want to do this because this would be the process that I would go through instead of just writing the query. So you see, even for Albania, you have a language, it's English. It's not an official language, but they do speak English in the country. So we want to keep all of those countries. Where language, and remember that is a reserved keyword. It turns, you know that because it turns blue. And when you are doing text values in Microsoft SQL, or not Microsoft SQL, MySQL Server, you have the single quotes to denote your strings, and those always appear in orange. Okay, so let's go ahead and run this. Now, whether it's the official language or not, we have all the countries speak English, at least to some degree. So, okay, now that we have that result and we know English, or the language is equal to English, we'll reduce that B data set for us, or that one that we are taking and doing the left join to table A with, your country table, is equal to English. Okay, so let's see which countries speak English and which don't. Okay, so notice we have matches by country on our country code. So these are the countries that speak English, or they say in that English, or the country language table, that they speak English to some degree. So part of the left join is to understand we found some countries that do. What about Afghanistan? We don't have Afghanistan in this data set because likely Afghanistan's in the Middle East and nobody really speaks English there, not enough to be significant. So when we try, we don't find that Afghanistan is in this country table. And since we're left joining, we have this null value. So we don't keep the values out of the B table because they don't exist. But we do keep the values for Aruba because one of the languages that they speak, country languages that Aruba speaks, is English. So we can tell the countries that do speak English, and by the nulls, you can see the countries that do not speak English. Does anybody have questions about this? And there was just a question. Simone, you said the where clause just after the join. So what would eliminate these null values is if you did an inner join instead of a left join. That you would keep, if you did an inner join, you would only keep these records where both the tables matched. So you would just keep this. Let's even do this. Now you're only keeping the countries who speak English. But you could also do this in a different way, right? You could do a left join. And then you could, let's run that again. You could eliminate those nulls from the where clause. You could say where language is not null. Okay. So what will this do? This will say where the language is not null. So it's just going to keep all these where there's a value that matched. Or alternatively, you could say where language is null. So there's not nulls, right? It's going to be where it matched between the two tables. So those countries that speak English. What if we say country where language is null? It's going to keep all of these countries where they do not speak English out of the left join. So you know in these countries they don't speak it. Well, at least it doesn't have information in the little country language table saying that they speak English. Yes, go ahead.
Is that exclusively like a MySQL thing? Because like I don't know, what I've seen before was that with left joins, if you have an and you have like conditions, it will remove whatever is not in those that meets those conditions.
It will remove them. Provide an example. This isn't a database specific
It's not.
syntax. This is common. Left join is common on all relational database.
Even with the and, like
Yep.
and language equals English? It doesn't.
Sometimes you'll see it like this. I combine it on one line sometimes to say, here's my on condition, and then I'm limiting it also in my on condition to the B table to language is equal to English. So not only can you join on the on, you can also have a limiting condition there to reduce the number of values or the number of rows that you're bringing in from the B table.
But that'll still result in nulls?
Yes, because we're doing a left join.
Oh, okay.
So how can we have both language equal to English and language is null at the same time?
Because remember, so null is the non-existence of a record in the other table, in table B. So that is, so we can go up. Let's go back conceptually to the left join. So we are keeping all of the records in A. We do that. Okay, so let's take this null out. It's just showing that for an example. So what is this doing here? So this left join, the A is our base table. It's going to keep all of the countries in the world.country language table.
So you can't put the where language is null in the same thing as language is equal to English.
Say that again. So you can't put the language is null.
Yeah, so you took out you had where language is null.
Yeah.
How can language be null and language be English at the same time?
This was just for an example, so watch what this does. Say if I wanted to eliminate these, this is just for example purposes. It would only keep the nulls after the join if I did it in the where clause. Somebody asked me, like, what if you did that in the where clause? So the where would take effect after all of that, but just ignore that. Just ignore that so there's no confusion. This right here is just a left join. Nothing in the where clause. And the left join, right, is that you keep all of the records from table A, world.country. And you keep the records from B where there's a match. So you keep the language from B where there's a match. And then the rest are null values. So there's no match here. It doesn't keep any records from table B, and it just sets it to null.
So then, sorry. Sorry, I'm sorry if I'm delaying anything. I was
No,
just
it's
confused
okay.
about like she said, how it could be null and English at the same time. Like that on part doesn't act like a where clause in a sense,
Yes, this part, if you do an and, it's like a where clause for this table, this B table.
but it still allows nulls.
That what? What's that?
It still allows nulls.
Yeah, that's what a left join does.
Oh, okay.
Yes, correct. So, how could I restate this? I'll do it one more time. How about that? Or let's go to like there's a Facebook example in here too. Maybe a different example. This example is confusing people. I am doing my best with this. Inner join. Maybe bringing up this example first would be better. And I see why I have missing slide or missing results. So let's do this. And this one should have probably been ahead of the code anyway. And it shows step by step exactly what the left join is doing. So we have the syntax. We did all this, right? We said from our table A, which would be like a Facebook, and we left joined our table B, which would be LinkedIn, on this matching key. So from the Facebook and the LinkedIn examples, the name is the match. That's the key that we want to join on, because that's the key between the two tables where it said, are these equal or are these not equal? And then also additionally, what we did in the world query is we limited our second table to down to a few less records. But let's just keep this example simple and just follow along with what the database is doing. So you're selecting star. So you're going to select all of the records from Facebook and LinkedIn, since we're using two tables. We're going to do a left join. So not just where they match. We'll keep everything from the Facebook table and then where it matches on the LinkedIn table. Otherwise, we'll give it a null value. And then we'll do that on our key. So watch this. So first we're doing mat. It found a match between the two tables. It found the match between the two tables for Lisa. How about Jeff? It did not. It found it is in the Facebook table, but it did not find it in the LinkedIn table. So we just kept Jeff and null results in the LinkedIn. So let's take a look at this one more time. We have Matt, we have Lisa, we have Jeff. We did not find Jeff in the LinkedIn table. He is in table A though, so he goes into that result. Since we didn't find Jeff in that LinkedIn table, we set those LinkedIn fields to null. And then we also found Sarah in the table. So we matched on those. Did this example help at all on what the database is doing and what the purpose of the left join is?
Yes, it makes sense.
Okay, I should have done this one first. I got it out of order because really you have to like start to understand like the data sets and like how the database is operating. Like now you have to understand like what am I trying to accomplish here? One is a question. And then you have to really understand the table and the keys between the two. And then how the database brings both of these together. And this is a good example of how it brings it together. And then our example after that is a little bit more complex than this. So if we go to our example, we have this result, and since we have records that matched between the two tables, we kept those records that matched in their fields out of table A and table B. But once we start having records that don't match between the table, there's no key match between this country table and then the world.language table where the language is English. So since it couldn't find a record where Afghanistan had English in the world.country language table, it sets those fields from the table B or world.country language table to null. Does that help clarify this, our example, and what it did?
Yes.
Okay. All right. So that's the rewatch. Okay. I appreciate it. I think it's just practice and then seeing how these, like the first time understanding how it comes together, or it can be hard. Just like practicing and joining these things and being like, oh, okay, now I like see how these, like I physically am like hands-on. I think it just takes practice to fully like bring that conceptual understanding down to earth. Okay. So full outer join, think of full outer join as a combination now of a left join and a right join. And actually that's exactly how MySQL thinks of it. So you are going to get, here, let's go back to from the current slide. So in these tables, you're going to get everything from table A, you're going to get everything from table B, whether they match or not, and then you get all the matches in between. So it's basically, and then, so let's go through this step by step. So think of this as like the left join. You're doing the left join first. You're getting all these matches between the two tables. You're getting where it doesn't match on that left table. And then you're getting where it doesn't match on the right table. So Lewis doesn't match in the Facebook table, but you're going to get Lewis because it's a full outer join. You get everything. So you get where it matches, where it doesn't match with the left join, and where it doesn't match with the right join. So this is like putting all of the joins together now. And this one is in your MySQL code examples. But a full outer join example here. Here's the question that we're asking. List the names for all South American countries that speak and don't speak English, while including all other languages that the countries speak. Okay, so let's say that one more time because I don't think I said that well. List the names for all South America countries that speak or don't speak Portuguese, which is this red part. And then just include all of the other languages here in South America that don't meet a country code. Okay. So the example, let's go ahead and break this down till it's multiple parts. Yeah, so that's just it. Just takes the aha moment to conceptually bring these together, I think. Just have to run it and like think about it and then see how it goes and then try different things. It just takes some practice. Okay. Simone had questions. Okay. Oh, we already answered those questions. Let's go ahead and see this in action. All right, so we have this, and we're in lecture 4. Inner join, left join. We don't have the full outer join in here. Oh, no, we do have full outer join. Okay. And there's a way that I could hide this. Okay, there goes that window. That helps. Okay, so here's what I want to do. So I want to run this in 2 parts. So here we go. So let's run this, the first part, that it's a left join. So you're going to get all of these countries where their official language is, where they speak Portuguese, not just their official language. Okay. Continent is South America, where they speak Portuguese. So in the right side, and I see why I do this a little bit later on, we're going to get all of the languages that they speak in South America. So we have all these different languages. To some degree, there's a little bit of these spoken in the countries. Because I know in Argentina, there is a Japanese population in Argentina, and there's some amount of people who do that. So all of these languages are actually spoken to some degree in South America, with Spanish being the most popular. And we haven't learned about this yet, but this is our right join. So we say all of those languages in South America, let's take them all, and then let's join world.countries to them. Or that's not what this says. It says all the countries in South America, let's join all of the countries or languages. This is actually spoken in the world. So what this does, all right, and this is, let's make sure we have the whole query here. So what this actually is you get all the languages in the world, and then you match wherever the country is South America. But that doesn't seem quite right, does it? Run that one more time. I ran in the wrong query now. Okay, one more second. Even for me as a pro at this thing, I sometimes have to decipher what the queries are doing or break it down. Let's get back to this one. Okay. This is the second part of it. So what does this tell us? So is this, you can try to put, if you're having a hard time understanding a query, you can put it into words. All right. So we're getting country, language, and language. This is a right join from the on the world.country language table. Are there any other conditions that are hiding over there to the right? Okay, there are not. So this is getting all of the languages in the world. And then after all of this is completed, this part, so if we were just to run this part, it'd get all the world count. It would get all of the languages spoken in the world. So you see things like Dari, you see some like language spoken in India and Africa and so stuff like that. We're going to limit this only where the continent is South America. So that is actually what this does. It does this part first. You limit this once again to the where clause. It'll get you only this language is spoken in South America. So I wasn't wrong at first. It's like Japanese, Italian, Spanish, and so forth. Okay. So we haven't learned about union yet, but now we can combine these two. We can get all these languages that are spoken in South America and wherever they overlap with the union statement, and then wherever the country speaks Portuguese. So a union is just bringing these two queries together to give you all these countries that speak Portuguese, and then all of the different languages that are spoken in South America. So it breaks it into two parts. It gives you all of that. It gives you where it matches. Well, it gives you all the where all of it doesn't match on the right join, where there are matches, and where it doesn't match on the left join. That's a full outer join broken down into two parts. So that's bringing it all together. We haven't covered union yet, but that's how you can append two result sets together. So I think everybody's probably about ready for a break, but let's get through the last slide here on joins. We'll take a good 15-minute break to let us recover and walk and get something to drink and eat and let it absorb a little bit. There's a lot of content in this one, especially conceptual content. But the common join pitfalls is that you're missing that on clause. So that on clause is important to tell the relational database system that we want to combine these two data sets together on a key. If you don't do that, it creates what is called a Cartesian product. So it basically becomes, or it does become, where all of the records are joined in A to all of the records in B, but each individual record in A is joined to each individual record, or all of the records in B. So for the first record, you'll get all the records in B. For the second record, you'll get all the records in B. For a third record, you'll get all the records in B. That makes this an enormous data set because it doesn't know what key to join on. It just tries to take everything. So that's what they call if table A has n rows, table B has m rows, m number of rows, it'd be n times m would be the number of rows that you get. So you never really want a Cartesian product, hardly ever. So if you don't have the on clause, it'll try to do that. It'll create this huge data set. It may run forever on a relational database or run out of memory. And that's because you forgot the on clause and potentially a condition with the on clause too. Okay. So another thing, you can do ambiguous column names. So the column name is ambiguous. So in our example, why it's good to use aliases on tables when you're joining them together is because, say you had, here's a good example. You had a name field in Facebook and you have a name field in LinkedIn, and you're trying to combine those together, and you don't differentiate what table the name is coming from. You don't give the tables aliases and the column names aliases. Then the database says, I don't know which database you want name from. Do you want it from table A, the alias that you give table A, or do you want it from table B? So that's why we do that here. So what this says is we give world.country an alias of A, world.country language of B. It specifies exactly, it's telling the database management system, we want name out of world.country in our result set, and we want language in world.country language in our data set. So it tells it by giving it aliases, it gives it tells it exactly what table that you want, and it avoids the ambiguous column names. So that's a problem that's solved by that. Here's one that we just talked about when trying to understand left joins, is that you forget the null behavior. So left join returns nulls for all those records that don't match from table B. If A is your A table, B is your table that you're matching to it, it will return null values for those columns in B where it's not matched, where it doesn't match. So not exactly not returning those columns, but there's no match, so there's no value. It's the non-existence of a value from table B, which is what makes it null. One fix that you can do is that if you don't want a bunch of nulls, you could use the coalesce function. We didn't cover it a lot when we talked about functions, but coalesce will allow you to input a value whenever the column is null. So you could coalesce a column, and then you could say no value instead of null. Joining the wrong type. So the problem is missing or duplicate rows and understanding the data before choosing your join. So the most important thing here is, oh no, it's the wrong join type. It's not the wrong column. I was reading this. So you do the wrong type of join. This could lead to missing values. So if you did an inner join and you meant a left join, maybe you'd be missing some of the values that you'd want from table A. So maybe you don't want them just where they match. Maybe you just want to see where they match and where they don't. That's really common. Maybe A is your customer table and B is invoices over the last month. And you want to do a left join to see which customers have ordered in the last 90 days and which one haven't. If you do an inner join, you only get where you have your customers and you have to match the customers who've ordered in the last 90 days. They have invoices in the last 90 days. So understanding that data before choosing the join is huge. That's some of the work that we did here, is understand each individual part, what you want out of each part, and then telling the database management system how you want to bring that together. And that's the different join clauses that you use, the join operations you use, whether it's a inner join, left join, those are by far the two most common, your right join, full outer join, or some combination of left joins or right joins using by eliminating or keeping null values. I like the best practice it has here. Always test joins with a limit of 10. So if you do a Cartesian join, like I said, it joins all the records on each table to each record, record by record. At least you've only run 10 of them, so it doesn't run like crazy. And it's a small result set. You can see almost exactly what you want, and you're like, yep, that's good. I want to run the full query. Okay, so that was a lot in the first hour and a half. I took time there because I would say this is the most difficult part of the class, is just to understand. You really have to understand your data, the question that you're asking, and then what the database management system is doing, what you want it to do, and how it's going to do it. And then that join operation that you want to use to get that result. A lot of being a data analyst is like, how do I bring this data together that management wants? Like, what's the question that they're asking? What information do I have available? And how can I bring all of it together? And you can do that with a SQL programming language. I mean, you could do it in Excel, maybe too, if you had a bunch of Excel sheets and did VLOOKUPs and stuff like that, or manually pasted things. But the SQL programming language gives you a programming language to be able to, especially with large data sets, be able to do that much more easily than doing it manually, or at least it would seem a lot less time consuming, I would say, at the very least, and less error prone. Okay, let's take a decent break here. If we don't get all the way to, well, we'll try to get to the exercises tonight. I wanted to get the homeworks out here too. So let us, everybody, take a 15-minute break up to 7:56. While you take a break, I am going to work on assembling homework 1 and hopefully get out homework 2 also. And just take a stretch, walk around, let it soak in or don't, either one. But I'm going to get up and get a drink myself while I do these other things. So any questions, drop them in the Slack. I'll take a look over break. And we'll come back. We'll come back at 7:57 now. 15 minutes from, it's 7:42 Central PM. Come back at 7:57, 15 minutes from now. Okay. See everyone soon, and any questions, drop them in the Slack. Let me know. See you in 15. Okay. Pause my camera. Pause my camera. Okay, there we go. Be right back. Okay, everyone, I'm back. I do have homework assignment ready. Actually decided to combine classes 2, 3, and 4 all into the same homework. We'll have that due on Monday. Mary, for you, you've already done part of the homework. You handed in part of the homework. I hadn't assigned it yet, but she did. You have done part of the basics homework. So nothing to worry about on your part. We'll have a comprehensive homework that will work on the Sequila database. It's taking the concepts we learned in the class and doing it on a more complicated data schema. Data schema is, well, a schema is a database in MySQL, but the Sequila database, which had the advanced homework, is it has multiple tables and relationships and takes a little more understanding of it's a film rental business with a bunch of tables. So you really need to go into like the tables and understand the database and things like that to put together your data. The basics, they are just questions, basic questions, making sure you know how to do things like structure a query, the clauses, how to write queries, structure and write queries, get data from tables, use some functions. Then includes class 3, which is storing, creating database tables, creating the layout, storing, updating, inserting, deleting table information, and then tonight's lecture. So I have that all packaged up. I'll do it here. I'll distribute it at the end of class. For now, we'll go ahead and get through the last part of this lecture. I think the last part of the lecture here, at least Union's a lot more conceptually easy, but subqueries can be tricky. So we'll spend a little bit of time on that. All right. Let's go ahead, get restarted. Let me get my mouse pointer up there. Where are you? Yeah, and one thing I was thinking about during break while I try to find where this mouse pointer is, there we go, is don't worry if you don't get something right away at first. I remember when I was in college, I was taking math and computer science classes, and I went out a lecture like just wondering what the professor even was talking about. And it's like a vague idea. But eventually, like, you go and do a little bit of work and you watch some videos, and eventually it clicks. Like, I remember in not a great example, but there's a calculus class. I studied hours and hours and I wasn't getting this concept. And like it's coming exam time, and just like right before the exam, it clicked and started to make sense after hours of working on it. So some of it's just like then going and listening to the lecture, going and repeating some things. You very likely like not get it the first time, but once you start doing the homework and you put it on paper and you play around with it, it's like when you start to really like figure it out. So don't give up just because you aren't understanding something. Always ask for clarity, of course, or raise your hand if you need some help understanding a concept, and then just give it a try and just work through it would be my advice. All right. So pep talk there, but it's true with these technical classes. Okay, so union and union all, we're going to use these Venn diagrams again. The union operator is used to append the result set of two or more select statements. So those graphs, those Venn diagrams on the right, they're facing sideways, but really you can think of these as up and down. So you're appending two result sets, like we've got with SQL queries, together, who have the same number of columns. And they must also have same data types. So going from left to right, like our example that we saw before, they both had, if you have column and language, or you have country name and language, and then you append it, or you do a union to another one, that's country and language. Those are both character string types. You can append those together, but you couldn't do is like append in English, like English, and then in another result set have numbers and then try to append the two. They both have to be similar types. And the columns in each select must be in the same order. So if you have country and English in one data set, you have to have country and English in the other. You have to have the same number and be in the same order. Then you can put them together. So there are two of these operators that you can do to append the records over up on the right. So you could do union. So if you have your first query and your second query, you append those together. It will allow for duplicate results. So if it finds a record in the first and a record in the second, it'll allow for repeats and duplicates. The difference between that and union all is that what union all will do is that it'll overlap those duplicates and only show it one time. So the way to think about union is that it allows duplicates when you append. Union all does not, because it'll overlap it if it appears in each one of the data sets more than one time. So I always like to present concept first. I know I not always get it the first time, but we'll have examples. I'm just presenting the concept, then we'll do some examples. Okay, so what does a union all do? So always start with this question over here. What question are we trying to ask? So list all the countries in North America that speak English or Spanish as a language and allow for duplication. So this top query, I wish I had my cursor again, but the top query, there we go, I had it for a second, is select name and country from world in your interjoining country language. So you're getting this first result set on country code where language is English and continent is North America. So this top result over on the right, that's above that line, that's going to be all of the countries that speak English that are in North America. So you see things like United States, Canada, Santa Lucia, some of those islands in North America, and so forth, Virgin Islands. So the result set down below is those countries in North America who speak Spanish, that speak Spanish. So then you start to have countries in North America. So Central America countries are still in North America. So El Salvador, Panama, Nicaragua, Mexico, obviously they speak Spanish there. And United States, of course, it's not an official language, but or have Spanish speakers here. And then what the union all does, it allows for duplicates. So you see where I've highlighted over on the right side, you have United States, where in a country that speaks English, and you append it because you have the same types of columns. You have name and country in each one of those columns. Or you have the country names in each one of those columns. So we have one column in each. We have the same number. in the top and bottom query, we have the same type. Both of them are variable character strings. So we can append both of those together and allow for duplicates because we have union all. So we see the United States is in both the English speaking countries in North America, and down below, they're the English speaking countries in South America. So we do have an example of this. I really did a bunch to explain each part, but we can also do that in code. We have this union. I really like with the union, just running it in two parts. Anytime you have a union or union all, you can run each individual part to see what result you get. So that's just a simple query that we learned in class 2, just getting all the country names, where they speak English in North America. I guess not quite simple because we're doing a join there. So we're saying world.country, world.country language, match those two tables on country code where the language from country language table is English. And then once you've done that match, filter out all those countries and limit it to North America. So let's see what this does. Run this first part. So your name, you have so that part, if you don't have this where condition, this gets all countries all over the world, like Guam and Hong Kong and Ireland and so forth. So then you add the where condition, and that will just be these North American countries. It takes that original result for all countries that speak English, limits it to North America. Okay, so the bottom part, we're doing the same, but it's just for Spanish. We have those countries in the bottom part that I described in the slide. And so we have two union operators. So in our slide, we did a union all, but let's do a union. So a union should not repeat any results. So if you have the United States in the top one and the United States in the bottom one, it should only appear one time in the final result set. So it does only appear once in the final result set. I would say that union all is more, or union is more like an or. It'd be like if it appears in the top one or the bottom one, let it go twice. And then your union all is like an and. So if it appears in the top one and the bottom one, include it both times. So we just covered union and union all. That's the only difference between the two. They all set up the same way. Union and union all. Union, like we just saw, is just that query that appends puts those two data sets on top of each other, the same number of columns and the same data types, and then eliminates duplication between the two. And this can have multiple columns. It's not just one column. You can put multiple columns together out of a table. Maybe you want country and country code and things like that. As long as you have those same columns that match number-wise, how many columns you have in each part of the union, and they're the same data types, you can append them together. Okay. Questions about unions? I think that one's probably a bit more conceptually easier than joins. With each one of these sections, I'll try to stop and ask if anyone has questions. Okay, so subqueries, this one goes to a little bit more challenging on how it works. So subqueries within relational databases, you can actually have queries within queries. Or if you think about it another way, a query reproduces a result set. You can have an inner result set from a subquery that is used inside of an outer query or a parent query. So if you have an inner query, it has to be enclosed by parentheses. So selecting, so what this top one would be saying, I really want my cursor for this one. Okay, I had it for a second. Okay, here we go. So must be enclosed by parentheses. So an example of a subquery, we'll do it in the next slide too. But there's sometimes queries that you can't really put together in one piece, like the logic that you write. And it's hard to show, well, we'll show an example, but it's really where you want to like take a small result set and then you want to build on top of it. You want to almost use it like a small table and then join other information to it. It's also a good way of like receipts and orders and customers. An example, maybe you would take all the orders as a subquery, like, and just limit it to a certain set of orders. And then you would join like in your outer query, join customer information or whatever else you would like. I think that'd be reasonable. Somebody was mentioning in class earlier, we will learn some advanced data structures that help you do something similar with temp tables or what's called CTEs. But this is conceptually, you can also write these often as subqueries too. So the most common one for me is that you can select column from table, and then you have a subquery in your where. So remember where is used to like select tables in a database? Well, really those tables are almost like result sets. When you select a table, it returns all the results from the table. But what you could do, and sometimes this helps from a performance perspective too, you would do like a subquery. Instead of bringing back the whole table, you'd bring back a small fraction of the table. And then you could use this subquery. Maybe you have your query, you could write it just the same way as you do any query in this. And this would be your subquery. Maybe you just want a small part of the table so that your performance is better. You limit it to just exactly the information you need. You use that in the where clause, and you combine it with some other information or summarize it in your parent query. So subqueries can do a few things. They can return a single value. It could just be like the sum of sales, invoice sales. It could return one value. It can return an entire row, a column's worth of values, or a table. This would be returning, or the example that I said here, it'd be returning a table or a result set. And these are always, but you can do certain things, and we'll see some examples, especially in a where clause where maybe you return a single column and you compare a bunch of values in the where clause to it. But so you always evaluate it from inside out. It's just like math, and inside of parentheses, you do what's inside of parentheses first, and then you get that result, and then you evaluate it in your parent query. And it's also used in the selector from clause. So not just the where, you can select. If you use it in a select clause, it returns a single value. Maybe you just want total sales for the year in your select clause. So you just go to a table, summarize it down to one value, and that's your total sales. And we'll see that. Or your from clause. Yeah. So let's go ahead and get some 3 examples of this. Okay. Let's actually run these. Let's run these as code examples. But what is the total population of the continent of Asia? This is a good example of like a subquery to limit the number of rows that you're bringing back to evaluate in the from statement. So let me answer any questions first to you. I think I have all of yours covered. Celeste. Okay. Let's go ahead and run these here, but always ask that question first. What are we trying to do with this query? All right, so this from clause is what is the total population of the continent of Asia? I mean, you could do this as a straightforward query too. This is just an example of how you could do this. You could do this as just a from world.country and then have a where as a continent of Asia. But we're going to do this. Let's say we want to do this as a subquery. We'll just get that information first. The name of the countries in Asia. We get the continent and name and the population actually from the world.country where continent is Asia. So we run this part first, then we take these results, and then we're just summarizing it by continent for all those countries, over all those countries in Asia. So let's run this part by part and be able to see it a little bit better. Okay. PowerPoint SQL. Make this just a little bit bigger. My code screen just a little bit bigger. Okay. So here's our query. We didn't have to write this as a subquery, but it illustrates any of the most common uses to not get the entire table, just get a smaller result set. So this inner table gets all of the countries in Asia and their populations. So we evaluate that first, and we take these results, and then we say by continent, by the population that we got in our subquery, because we put that subquery in parentheses and gave it an alias, a continent, population, and then we just want to sum that population over the continent value. So summing over all these countries for the continent of Asia. Let's see if that's what it gives us. And we get the sum of those countries that were in that subquery in the continent of Asia. It's about 3.7 billion people. Seems about right. Always, one thing I always do is I think about the result of the query also. Like, does that result make sense? If it doesn't, then you have to think about like how you're joining things or how you're bringing this data all together. Or maybe it's a condition or something that you're missing. It's always just like problem solving too or diagnosing is just break it into small parts and see which part is broken or not working. I would also say subqueries are useful for that. If you have like 10 joins, you could have as many joins as you want in a query in theory. You could get part of the result, do part of the result in a subquery, so it makes the query less complicated. So you get part of your result, and then you finish the result within another query. Or, I mean, you can start doing crazy stuff like nested queries, like 3 times, 4 times, 5 times deep. But we'll learn in this class that gets hard to track what's going on too. You have to do it piece by piece. And there are things, other advanced SQL techniques that I personally think are better fit for that type of construction of a result set in SQL. But for now, subqueries in the from statement can definitely make it easier, and sometimes you can get even better performance out of it if you narrow down how much you're bringing back in that subquery into your result. Okay. So it showed how it worked. We did that by example. Okay, so we're going to put one in the select clause. So this is an example, it's one that I was kind of explaining earlier, and I don't have the COVID-19 database set up, but we'll go through this example anyway, because I think that we can explain our way through it. From current slide, I'm going to lose my mouse cursor, I bet. Yeah, or maybe not. Got it. Okay, so say what national versus state proportions for the COVID-19 cases by region. So this is a case where we want a result set where we have the total number of cases of COVID. And we want to divide, or we want to take that and the number of state cases and take state cases divided by the total number of cases to get the percentage of COVID cases by state. So there's this result. These are all the cases in the United States. These are the cases by state. And we do cases by state divided by United States cases to get our percentage of the cases that belong to each state. Okay. So this would be one that maybe you couldn't even do unless you had a subquery or broke it into separate parts. So what are we going to do here? So you can see it's in our result set. It repeats a bunch of times. But we're going to put the total number of cases as a single value that you can return. So remember, you don't have to necessarily return an entire table. You can return a single row, column, or even a single value. We're returning a single value in this one. So with that select max S1 cases from COVID-19, it's total US cases. That's just a straightforward query. That's just summing all the cases over all of the states in the United States to get that total. We take that value and then we include it in our subquery, and what it does, it takes that single value and repeats it for every row. Okay. So the second one, we could also do a subquery to get this by state. It's say get the cases COVID-19 as S1 by state. Or wait, that's not what this does. So we reuse that subquery. Okay. So this mouse. So we're reusing those total US cases. That's what the red is there. Let me try to get my mouse back up there. Trying to get it so I can use my pointer. Okay. it there? Yep, success. Okay, so this is the total U.S. cases, max cases from COVID-19 U.S., which is the number of cases in the United States. Okay. So to get a proportion, we can do this sum by U.S. cases as state cases. And then we could do this U.S. cases divided by that single value that we get out of that subquery. And what that does is that it takes the sum, takes the total U.S. cases, creates our proportions out of it. So that's how you could use a single value as a subquery within a select statement. You could, in theory, return an entire column, but it gets messy. It would start potentially repeating values a bunch of times. This is harder in a way. The best I would return scalar values within more often than not within a select statement. So this is where you would use it, where it's like two different aggregation levels, and you need a subquery that returns a value to be able to bring these all together. Otherwise, designing a query for this where you join data it'd be more difficult to do. All right, getting near the end. All right, and then we could do one in the where clause. This is probably, I'd say, the second most common next to the from statement. So what does this thing do? And we don't have this COVID table loaded either, but we'll explain what it does. I create some new examples, but it does help us on a new data set to some degree. Okay, so maybe we want to get a COVID-19 state level information for all states that begin with N. So we want a list of states who return values in a column for an in statement. So an in statement is in the where clause where the field can match any one of those values. Let's think about what this is doing. So let's just start with this. Well, yeah, let's just start from the inside out. That's the way you always evaluate a subquery. So a subquery, you need to select distinct state. So you can just select this, just no repeated values from your COVID-19 US states, where, and we have a limiting condition for our inner query, where the leftmost character, so you start from the left in state, where the leftmost character at position 1 is N. So let's try to blow this up. I keep losing my cursor every time I do it, which is why I haven't been. But what does that give you in your subquery? It gives you Nebraska, Nevada, New Hampshire, New Jersey, New Mexico, all the states to start with N. Okay. All right, so we have that result set. We say where the state is in any one of these values, those are the states we want to return results for. So let's take that, we evaluate that, and then we do our outer query. So from our US states table, select everything in the US states table where the state is in the value of one of these. So select Nebraska, Nevada, New Hampshire. And then once that's done, we can give it another limiting query. We could say, and the date of the COVID-19 result out of the United States table is equal to 10/15/2021, and then limit it to just that state. So You see, you can get that as a list of values included in an in statement to be able to filter exactly the values you want out of another table. That helps. The biggest thing that helps with is instead of like entering all of these values manually in a where statement, you can just get those as a result of a query instead of having to enter them all manually. And sometimes you would have to do that because in an in statement, maybe it's part numbers, and maybe you have 10,000 part numbers you want to include in a query. You almost have to put them in a table and then select them as a subquery in the where clause instead of entering 20,000 values into an in statement, or doing and part number is equal to 1 and part number is equal to 2 and doing that 20,000 times. So there is value to that using a subquery that way also. Anybody have questions about subqueries? How they can be used in different ways? What the point of them is? No? Okay. I'm going to give a moment through the class, entire time through the class. We do have one. You have one. Is Celeste? I already got it. Okay. We've been through a lot tonight, so let's wrap it up. All right, so let's review what we learned. In SQL joins, combine rows from 2 or more tables. I just started it from the beginning. Bad habit of doing that. Combines rows from 2 or more tables based on a related column between them. So you can do an inner join, left join, or full outer join. So what that says in different terms is, depending on the type of join you have, you can combine the rows and columns from those 2 different tables based on matches with each other in different ways. Whether it's an inner join, a left join, right join, full outer join, or something in between. We learned about subqueries, which is a query that's nested within a select. You could also do this in an insert statement, like you do select in a from clause. You can do a subquery and put it in an insert, update or delete statement also, or inside another subquery. So you can nest subqueries together. So subqueries can be used anywhere. That's a regular query, or it inserts, updates, and deletes also, which I didn't mention before. So it can be used in a number of useful places. All right. So that gives us a little bit of time to do some practice exercises, and then get this homework out to you. All right, so let's do these practice exercises first. So exercises we want to do is, I think these are also included in your homework too, but we'll go through these together in class, and then you can take them home and do these exercises yourself and submit it. So this would be for the basic assignment where we're just making sure that we're familiar with joins and unions and subqueries. Okay. And then the last 2 slides in this, we talk about additional resources for what we learned today, and then what we're doing in the next. We're going to do, so we'll start doing some applied work in the next couple of classes. Okay. So exercise 2, be part of the homework. So if you watch the video, it can help you out with your homework. But since we're joining tables now, we have relationships between these tables. And the relationships are not just primary keys for a table, but it's a relationship between those fields that match each other between these tables. And sometimes you'll have direct matches. You'll have one record from one table that matches one record for another table, or maybe it's many cities that match a single country. You'd have a many to one and so forth. All right. So you could have a couple different types of relationships, and depending on the joins you do, this are the results that you'll get. But this table shows you those tables. So country, city, and country language. This is all of the tables in the world database. And then all their fields, their key columns, and then how they are related to each other and what type of relationship. So having this type of diagram will help you also understand how you should put together your queries and what should be in your on clause, what fields should be on your on clauses. So I always use a combination of these diagrams and then just looking at the tables themselves to understand the values that are inside of them. All right, let's do it. So let's do using a union on the world.country table. Combine all countries with a life expectancy of 80 years or a GMP of, I think this goes by thousands. So a billion, 100, yeah, a million, and add a few zeros would be a billion with no repeats. So I think I have. So this has all of the exercise, the class exercises here. Let me really quick find the examples or this homework that we'll do for homework 4. Give me just 1 second to get these. I had them out. One second, pull up these results, or I could just try to create these queries myself. Shouldn't be too much of a problem to do that. Oh, class 4 exercises. There we go. Let me pull these up here. Okay. There we go. Found it. So class 4 exercises, I'm not going to give this to you because I'm going to give this file to you because I'll give this to you as homework. But of course, if you watch a video, it'll help you out or give you the answers. So just a hint for people who are here or get stuck. All right. So that first question, using the union, combine all the countries with like expectancy of 80 or GNP of 1 billion with no repeats. So that or statement with no repeats, that says that we should use a union clause between two different result sets. One with the life expectancy of 80 and then the one with gross national product of more of a billion. Okay. So really simple why I like unions. So you can break them into two result sets. So this one is you're just getting the name of the country. You could even do stuff like multiple columns, like a gross national product and life expectancy if you wanted to. And then join those together. And they don't even have to be named the same. They just have to be a similar types. But we'll eliminate those. Let's just get the countries from each one of these. And we'll do the other ones next. So life expectancy of greater than 80. You have, surprisingly, you have Andorra, but you have Japan, Singapore, San Marino. We have 5 in that result set. Okay. For the union, what do we have here? We have Japan again in this one. So if we have a union, we should see we had 5 in the first one, 5 in the second one, or we have 6 in this one. But we should see Japan only appear once if we do a union. So we should have 10 total after we do this, after we combine the two. That's what happened. We get 10 results. It combines the first set with the second set. And since it's a union, there are no repeating values, including Japan. And then, of course, with a union, if you wanted to do more values, say you wanted to bring gross national product and life expectancy into each one of these, you could do that also. Oops. I don't know why I wouldn't have just chose these fields since it's both from the world.country table. Okay, so now you can see the gross national product and life expectancy. And then you could say, well, Andorra was included because life expectancy was greater than 80. Japan actually meets both, but is only included once because of the union. Macau would have a life expectancy at 81.6, so it's included in the top. But countries like Germany, France, United Kingdom, Italy, United States, those would all be included in not the life expectancy of this query at the top. This query and that was included in the final result set because of that query at the bottom. So a good way unions are evidently effective, use them quite a bit, especially to break down those problems into 2 simpler result sets and then just bring them together. I find unions to be very useful when I'm working with data. Then if you were to do a union all, just to show you, you would just repeat Japan twice. There's Japan once, and then Japan twice because it's in each one of those result sets. So choosing between union and union all can make a bit of difference. Okay, about 12 minutes left. Let's try to do some work with some joins. Okay. So 2 is list all official languages spoken in the Southwest Asia region. So where might we be going with this? What tables do we need to compile this information? So first, I would look for region in, where can we find region in this schema? Right, we find region in the country table. We know region is in country. And then it's list all official languages. So kind of knowing the database as analysts now, we know that the language information is in the country, is in this country language table. And you say, okay, we have 2 tables. We're going to have region out of the country table. We're going to have language and is official out of country language. How can we bring those two together on a common key? And this diagram actually outlines that. You can bring code from country together, and you can bring country code from the country language table. So we're actually kind of familiar with that because we used that as an example earlier, but that's how you could use a schema to determine what tables to join. All right. So let's go ahead and put all of this together. So since we needed it out of two tables, that's going to be a join. We said it's going to be an inner join because we only want the records where there's a direct match between country language and country where the language is official. So we're limiting the country language down to is official is true. We saw that earlier. And we're joining the tables on this key. Okay. So we do that to world.country and limit this world.country table to just Southeast Asia. Just Southeast Asia countries. So we even just to highlight a little more. Yeah.
Is there a difference between putting region in the on clause or in the where clause? Is there a difference to do that?
Give it a try. I think that you can still do this in the on clause. I do it in the where clause just to separate, because this one's like our base table.
Oh.
Just to separate it from that on clause where we're doing work or we're doing limiting conditions on the B table. Well, let's go ahead and see if that works. I think that it does. If you did that and A dot region is Southeast Asia, let's go ahead and try it. Okay, that returned 10 results. So let's go back to the other way. And 10 rows returned. So it actually returns the same result. So you can do that in the on clause. So this is how my brain works when I'm putting this together. So I'm doing this from your base table of world.country. I always think of like your A as like your base table, the first table that you're using. I'm limiting it down to Southeast Asia. And then I'm joining the world.country language table on that key and limiting that second key or table to just official languages. So it's like, for me, it like separates the conditions. It helps me separate the conditions of the two tables. And I like, in general, just putting the conditions of the table that I'm joining in the on clause. So they talk about like style in SQL in this class, or best practices, but there's not really a whole lot of that in SQL. Maybe there's some organizational practices, and occasionally there's ways where you can get a little efficiency gains out of how you arrange these clauses. I'm not too worried about teaching that in this class. I just try to like logically trying to keep it simple, at least from like how my brain thinks about it. So that's the challenge in SQL, is like, it's like math, where there is like a right result, but there's not just one way to get to it. There are a couple of different ways to get to it. And you could write the query a little bit differently and still get to the same result. Does that help?
Yes, sorry.
No problem. I've just been double checking with everyone in this class just to make sure. All right. Just make sure it comes over loud and clear. No misunderstandings. This one's probably like the hardest. I think the hardest, like I get said a bunch of times, but the hardest lecture when you're learning it. Okay. Where'd my cursor go? It's always battling. Let's see. What do we have next? Let's do one. We have a union. Let's see. This one, number 4, kind of combines a couple. And then we have a from and a select subquery. So let's do number 4. So let's do world schema. In the world schema, use a union to obtain the name of all cities in North America that have population over 1 million, where the primary language is English or Spanish with repeats. So what this is going to do is that we're going to take those queries where we had to join 2 tables together, like we had to join country and country language 2 separate times and stack those inside of a union. All right, let's see how that works. We did 4. So we have this language, or we have this query on top. So this would be, actually, we made this fairly complicated. All cities in North America that have a population over 1 million, where the primary language is English and Spanish. So this actually brings in 3 tables because you need some city populations in this first query. So this was our first example of, we have world.country, and then you join world.country language to this table, and then you join world.city to the A table to get your final result. So let me walk through how this works. Okay. We can actually do this in a couple parts. So let's just narrow it down to 2 parts, what we're used to. This is going to get your continent, your country, official language. And then for now, we need to take the fields out of the C table because we're taking that out of our join for the minute. So breaking this into 2 parts. So we have North America. We have all the countries in North America where their official language is English. Okay. And then say we want to add city information. So it says, let's join on this country code. We have where we're joining all the tables. Let's get all of those cities where the code meets the country code and all the cities in the world.city table with the population over 1 million. Okay. So now we can uncomment C because we're using that in our query. So we're getting fields from table A, table B, and table C. And we have North America, Canada. You have the cities in Canada like Montreal. You have all the cities in the United States, population more than 1 million. I guess in the other countries, they didn't have any cities with over 1 million population. All right. So we did that in North America. So the bottom query, how is this one different? Oh, where official language is Spanish. So this is going to add some cities in Mexico. So that's all the English-speaking cities in North America with population where their official language is English, population more than 1 million. Right. So now we're doing that same thing, but we're doing Spanish. So now we have Cuba, Habana, Cuba, Guadalajara, Mexico, so forth. Lots of Mexican cities. Okay. So that's how you can take two kind of complicated queries, break them down into each one of their pieces. Now we can we can union all these together. So all the cities in North America that have a population more than 1 million, where the official language is English or Spanish. There we go. So we have Canada, United States, and then those where the official language is Spanish in Mexico, Dominican Republic, and Cuba. Okay. It is right at 9 o'clock. I will do one last example with a subquery. We have some subquery examples here. Or I thought we did. Let's see what the last ones were. And I still owe homework to everybody. So right after class, I will paste the homework here into Slack. It will be due on Monday. It will include questions from classes 2, 3, and 4. We'll combine homework 1 and homework 2 into one. Have them due as Monday. Have them due Monday. So yes, so in this exercise, and I actually should go over that really quick. You can create a from subquery in the world schema and create a select subquery. I guess that's because I didn't have a result because I just allow people to create a subquery on their own. Be creative and create a subquery in the from and select statements. And I check it, and anyone can be, as long as it's working, it can be acceptable. Okay. Let me cover homework super fast. So we have 2 versions of this homework. We have a basics homework that's going to test just your basic skills out of each one of the sections in the first 4 lectures. Not so much out of the very first one because that's defining. That was just defining relational databases and storage and tables and databases and things like that. But everything that you've done in there, you put together queries, aggregate functions, data manipulation, so inserting data, updating records, modifying table structures, creating your own tables. And all of these have breadcrumbs along the way. So giving you an example of code for you to write. On all of these, I would like your responses to be the code that you write plus a screenshot of your results. So under each one of these tasks, put the code that you created and a screenshot along with it. So this is the basics homework. It says it'll take about 3 to 4 hours total. A lot of these are examples that are similar to what we have in the class notes and lectures. So if you struggle with it, go ahead and take a look at those. ask ChatGPT for some advice. And if all else fails, feel free to reach out to me about it.
Are you speaking to the exercise homework 2 slide?
Oh, sorry. This one. I had it pulled up on my laptop screen and was talking to it. So here we go. Sorry about that. I'm wearing out too. So everything in the first three, in the first 4 lectures, not so much from the first lecture, but select, aggregate functions, and all these different topics all the way through joins and subqueries. This is the basics. This is what I'm looking for as a baseline for your understanding. I do include code snippets to help you out, to be able to run code. What I'd like from you in each one of these is the code that you create. You can just put it in the Word document and screenshot your results on each one, and then hand the file in when you're completed with it. So this is the basics assignment. If anyone would like, I also create a more advanced assignment. So this would take 3 to 4 hours. The other one would probably take about 6 to 8 hours. So it'd take up a couple 4-hour working sessions on the weekend. But this is more related around a business scenario, and it's a more complicated database. So it's the Keela database, which is, we haven't done any of the examples off of that because it's a more complicated schema. But it is realistic of a DVD video type rental store system that you would potentially pull data out of. But so this one has more of like a business scenario and creating the database and inserting your code and exploring the tables and so forth. So you don't have to do both homeworks. I want to make that clear. You can choose one or the other. You could do both if you really like, but choose one or the other, and I'll grade accordingly. Because I know in this class, there are various levels of like skill and previous knowledge. That's why I give both options. And I'll grade all of these with feedback. And if you create the basics, that's a pass. And then if you pass the comprehensive homework, they'll give you a high pass for that as a grade. Is it clear what I'm looking for the homeworks?
Yes.
Yes.
Okay. These will be the documents. I'll hand these out right after class, due Monday, upcoming Monday. All right. We survived, everyone. Thanks for asking questions, making sure it's clarity. I said it like 10 times, but most challenging lecture. And it just now takes some work and working through these practice exercises and playing around with the data and getting your hands on it and really understanding what different things do. If all else fails, like I said, you should let ChatGPT help you with your learning. Don't spend like an hour and a half just stuck on something small or you can't figure out or why it's doing something. Put it into ChatGPT or put it into Claude and let it explain to you what it's doing or what the error is. It'll speed it up greatly. Don't necessarily use it to do your homework. That's not the point. But use it to help accelerate your learning and get you past sticking points so you don't take a 4-hour homework and turn it into a 10-hour homework. and reach out for help. All good? Maybe not
Yeah, thank you very much.
all good, but we'll get there. Goes by fast. We actually have only 3 more classes after this, and one's final and interviews. So we have a couple applied classes coming up, like realistic. Like once you learn these basics, this is like the end of the basics. Well, this isn't quite a basic, but this is like a fundamental. Now we'll start to do applied work. We'll start to apply everything that you've learned, what you might do as a data analyst or SQL developer. Well, that is it for me. Jaw's actually sore from talking a lot, so need like a drink. I feel everyone enjoy the night. Yeah, you have 7 days to work on it. Do it piece by piece or all at the same time. Personally, I like to do things all at the same time, just sit down and lock in. But however you choose, whatever works best for you. And I'm here always here till 9:30. So any questions you have about class so far? And of course, everyone have a good night.
Good night. Thank you.
Yep, you're welcome. See you Wednesday.
See you.
All right, so that is it for this lecture in Omaha Data Science Academy. This covered joins, subqueries, and unions, merging data. And for our next lecture, we will start, as I said, we will start to apply the knowledge that we learned into cleaning data using SQL. So we'll take those operators, use a lot of case and like statements, start to learn about wildcards, about finding substrings, cleaning up data, and like statements, some logical functions, removing duplicates, cleaning and formatting data in date times. It's a big part of a data analyst job. So this is Jeremy Bergman, Omaha Data Science Academy. We will see you next time. Thanks, everyone.